Assalamualaikum. Today our group will be present about ground subsidence in Jakarta. Ground subsidence is a gradual sinking of the ground surface caused by the loss of underground support. This problem mainly caused by excessive groundwater extraction and urban loading from rapid development. Jakarta is the one of the most affected city because many residents and industries rely heavily on groundwater. Continuous groundwater pumping weaken the soil and cause the land to sink over the time. As a result, several subsidence has been observed in several areas of Jakarta. Ground subsidence in Jakarta gives real impact to society, safety, environment and infrastructure. From a societal perspective, many people experience property damage, economic losses and community displacement due to repeated flooding. From the health and safety perspective, building, roads and drainage system may become damaged, increasing the risk of structural failure and danger to the public. From an environmental perspective, land subsidence increase flooding and seawater intrusion, especially in coastal area. This issue also highlight the importance of groundwater control, proper urban planning and engineering standard to reduce future risks.
Good morning, everyone. Today, I would like to present the problem of the land subsidence in Jakarta, where Jakarta right now currently facing a several land sinking caused by the excessive groundwater extraction, rapid urbanization, and heavy infrastructure development. This issue has created a major impact on the safety, society, and the environment. Okay, firstly is a safety and infrastructure issue where the most immediate threat is the physical collapse of the city foundation and the failure of the protective barrier. For the structure failure, which is causing by the settlement by differential sinking, leading to severe cracking in building foundations. For the breach of the coastal defenses, with 40% of Jakarta already below the sea level, where the city rely on the sea walls. The emergency response paralysis, where the rapid land subsidence create bows where the floodwater cannot drain naturally. This leaves the key emergency road submerged for days, preventing the medical and fire service from reaching the resident during the disaster. Okay, for the second issue is the societal and economic impact, where the city of Jakarta create a deep divide between those who can afford to adapt and those who cannot afford. So the environmental injustice, where the hardest hit area are often the kampongs along the coast, residents here face a permanent flooding, where they must rebuild their floors every few years and or they must live in semi-submerged conditions. For the livelihood replacement, which is the fishing communities, like those in Muara Angke, the construction of giant seawall to stop the sinking cut off their direct access to the sea and destroying their primary source of income. For the mass migration, the sinking capitals, the problem here is that several it has a force in the state government to move the capital to Nusantara, while the soft, the administrative issue, it leaves behind 10 million residents in Jakarta who must still deal with the sinking economy and declining property values. Okay, the third issue is the environmental impact, where the ecological balance of the region is being permanently altered by the intrusion of the seawater. Okay, the first is saltwater intrusion. As the ground settles and the groundwater is over-extracted, the vacuum is filled by the seawater. This turns freshwater aquifer contaminated by the seawater and also reduce the clean water supply. The second is loss of mangrove forests. Land subsidence combined with the urban sprawl has led to the destruction of mangrove. Without this, there is no natural protection to against the coastal erosion and the tidal surge, and it reduces the natural flood protection. So the third is the reverse hydrology, where the Jakarta 13 rivers now struggle to flow the ocean because the land they pass through is lower than the sea. This the river into stagnant and highly polluted canals that back up into resident street at the slightest rains. This increases the stagnant water and urban flooding.
For this slide, I will explain the professional roles of civil engineers in addressing land subsidence issue in Jakarta. Firstly, civil engineers are responsible for protecting public health and safety. Engineer must conduct geotechnical investigation before construction to identify soil condition and subsidence risks. They also monitor soil settlement and groundwater level continuously to detect abnormal ground movement early. In addition, engineers assess the structural stability of building, roads, a bridge, and underground utilities to ensure infrastructure remains safe and functional. Mitigation measures such as foundation strengthening, drainage improvement, and flood control system are also implemented to reduce the risk of collapse and flooding caused by land subsidence. Secondly, civil engineers play an important role in engineering analysis and risk assessment. Engineers analyze the causes of subsidence, especially excessive groundwater extraction and urban development activities. Technologies such as satellite monitoring or INSAR, GIS system, and settlement sensor are used to monitor land deformation accurately. Through this analysis, engineers can evaluate the environmental, economic, and societal impact of subsidence on urban infrastructure and surrounding communities. Lastly, civil engineers contribute to sustainable infrastructure development. Engineers promote sustainable groundwater management to reduce excessive groundwater pumping. They also improve drainage and flood mitigation system to reduce flooding risk in low-lying areas. At the same time, engineers work to minimize environmental degradation and support long-term sustainable urban development in Jakarta. For this slide, I will explain the ethical obligation of civil engineer in handling land subsidence issue. Firstly, engineer must act honestly and professionally in all engineering practice. They are responsible for ensuring that all design, report, and engineering decisions are carried out ethically and based on accurate technical information. Secondly, engineers have the responsibility to protect human life and the environment. In the Jakarta case, engineer must ensure that infrastructure remains safe and that engineering activity do not worsen environmental problems such as flooding and groundwater depletion. Besides that, engineer must report engineering risks transparently to authorized stakeholder and the public. Any risk related to land instability, structural safety, or groundwater extraction should be communicated clearly to avoid future disaster and infrastructure failure. Finally, engineer must make decisions based on technical evidence and safety standard rather than economic interest alone. Engineering decisions should prioritize public safety, sustainability, and long-term infrastructure performance to ensure responsible development. Okay, next, I will explain the importance of regulatory compliance in controlling land subsidence in Jakarta. Firstly, Indonesia Water Resources Law number 17/2019 regulate groundwater extraction and permit requirement. This law is important because excessive groundwater pumping is one of the main causes of land subsidence in Jakarta. Engineer must ensure that project comply with groundwater extraction limit and sustainable water management practice. Next, the Ministry of Environment and Forestry Regulation number 17/2012 required monitoring of ground deformation and groundwater level. This regulation helps engineers and authorities detect early signs of subsidence and implement mitigation measures before several structural damage occur. In addition, Jakarta Regional Regulation number 20/2011 restrict deep well drilling in critical area to reduce excessive groundwater usage and minimize further land sinking. Civil engineer must ensure that construction project follows this groundwater restriction and environmental requirement. At the international level, UNESCO Land Subsidence Guideline provide reference for sustainable groundwater management, hazard mapping, and subsidence monitoring system. Engineers use this guideline to apply best practice in mitigating land subsidence risk. Lastly, ISO 14001 Environmental Management System promote risk-based environmental planning and sustainable resource management. Through this standard, engineers and organizations are encouraged to minimize environmental impact and improve sustainability performance in infrastructure projects. Next is about stakeholder and conflicts. Various stakeholders are involved in these Jakarta land subsidence issues, including government authorities enforcing groundwater regulations such as Indonesian Water Resources Law number 17/2019 and Jakarta Regional Regulation number 20/2011. Also, civil engineers ensuring compliance with UNESCO guideline and ISO 14001 standard. And developer and industry contributing to groundwater demand through urban development activities, local communities affected by flooding and infrastructure damage, as well as environmental agency and researchers supporting sustainable groundwater management and subsidence monitoring. Conflict arises between stakeholders as developer and industry prioritize rapid urban development and economic growth, while government authorities, environmental agencies, and civil engineers must enforce regulations such as Indonesia Water Resources Law No. 17/2019, Jakarta Regional Regulation No. 20/2011, UNESCO Guideline, and ISO 14001 standard to ensure public safety, environmental protection, and sustainable groundwater management. Conflict also occur when local communities and industry depend heavily on groundwater for daily activities and operations, while authorities attempt to restrict groundwater extraction under Indonesia Water Resources Law No. 17/2019 to reduce land subsidence. Therefore, civil engineers should propose sustainable solutions such as alternative water supply system, artificial groundwater recharge, and continuous subsidence monitoring in accordance with UNESCO guideline and ISO 14001 standard.
Next, I will present 3 engineering solutions that can help reduce and prevent ground subsidence. These solutions focus on sustainable water management, ground improvement techniques, and smart urban planning to improve safety and reduce long-term environmental and infrastructure damage. The first solution is sustainable groundwater management. One of the main causes of ground subsidence is excessive groundwater extraction. When too much groundwater is removed, underground soil layers lose support and begin to compress, causing the land surface to sink. To address this issue, engineers can implement groundwater control measures such as limiting groundwater pumping, using rainwater harvesting system, and introducing groundwater recharge methods. For example, recharge well can help return water back into underground aquifers. Smart monitoring system can also track groundwater levels in real time. This solution help reduce subsidence rates, protects underground soil stability, and support long-term water sustainability. The second solution is soil stabilization and ground improvement. In many urban areas, a weak or compressible soils cannot safely support heavy buildings and infrastructure. As a result, the ground settles over time and causes structural damage. Engineers can improve soil strength using techniques such as deep soil mixing, vibro compaction, and jet grouting. These methods increase soil density and improve the load-bearing capacity of the ground. Ground improvement is especially important before constructing roads, bridges, and high-rise buildings. This solution improves structural safety, reduces settlement problems, and increases the lifespan of infrastructure. The third solution is smart urban planning and monitoring systems. Rapid urbanization and uncontrolled development can increase pressure on the ground and worsen subsidence problems. Therefore, continuous monitoring and proper planning are essential. Modern technologies such as satellite monitoring, also known as INSA, can detect small ground movements before serious damage occurs. Engineers can also use GIS hazard mapping and ground sensors to identify high-risk areas. In addition, authorities can restrict development in subsidence-prone zones and conduct regular geotechnical assessment before construction project begins. This solution improves public safety, supports sustainable urban development, and help prevent future infrastructure failures. In conclusion, ground subsidence is a serious engineering and environmental issue that requires sustainable and long-term solutions. The 3 proposed solutions are sustainable groundwater management, soil stabilization, and smart urban monitoring system. Together, this approach can reduce infrastructure damage, improve public safety, and support sustainable urban development by applying proper engineering practices and regulations. The risk and impacts of ground subsidence can be significantly reduced. Thank you.
There are several solutions proposed to reduce groundwater subsidence in Jakarta. The first solution is sustainable groundwater management. This method can reduce land sinking and help save groundwater resources. However, it is expensive and difficult to control groundwater usage. The second solution is soil stabilization and ground improvement. This method can improve soil strength and create safer building and infrastructure. However, the cons is required high cost and specialist expertise. The last solution is smart urban planning and monitoring. Technologies such as satellite monitoring can provide early detection and improve future city planning. However, it requires expensive technology and takes time to implement. Next, I'm going to talk about long-term impact. If this issue not controlled properly, Jakarta may face more severe flooding and seawater intrusion in the future from the environmental effect. Next, from the society, community may experience more property damage and some people need to relocate to safer area. Next, for the engineering aspect, infrastructure damage and repair costs will continue to increase. However, effective solution can help create a safer city and support better future development. In conclusion, ground subsidence in Jakarta is a serious engineering issue, mainly caused by groundwater extraction and rapid urban development. Therefore, controlling groundwater use, improving soil condition, and implementing better urban planning are important to reduce future risks and ensure sustainable development. Thank you. That's all from us.